Hey everybody, Jason here. I hope you're all doing really good. You all probably seen a recent community post that I made with some photographs of an LG G5 that I recently recovered by swapping the flash memory and the CPU over to a known good board. Now, I'm actually holding the old board here, and I want to go over with you exactly what happened leading up to the board swap. The customer threw this phone and shattered the screen. I installed a replacement screen, battery, and USB-C flex cable. The phone still does not power on. I do not see any defects to the board with the naked eye. Phone repair if possible, data recover if not possible to repair. So I'm actually holding the old board right now, and I would like to go over with you what happened leading up to this. So down near the bottom of the board here, this is where the modular charge port thing hooks up. And right next to this here, initially, I had noticed that this inductor here was completely broken away. Now, I do not have board views or schematics for this, so I just sort of, grabbed another one and blindly replaced this. That didn't make a bit of difference. What this board was doing is whenever I would hook it to the power supply, it would draw just a tiny little bit of power and then stop. It was like 40 milliamps as long as I was holding down the boot prompt button, and that was it. It wouldn't prompt to boot. So without having schematics, I'm really just left with looking for shorts and weird readings in places, but mostly just visibly inspecting. Now, on the back side of the board, it was obvious that this shield back here was smashed, and you can see that that's been removed here. It's not on here right now. But this shield, it had been all dented in and was actually folded like around some of these ICs. I've pried it back up now. This little IC here, this was completely shattered. This was a WTR IC, which, fun fact, I wound up finding out it's the same exact IC used on like an iPhone 7, so that's pretty stinking cool. So then, we have an inductor broken down here toward the bottom of the board. We've got this metal shield like punched in, and you can also see ever so slightly where it has sort of misfigured the logic board where this impact was, and drawing a very, 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 very tiny amount of current. Now, one of the first things that I noticed about this board is that there was no underfill on the CPU or the RAM, and having this serious impact, not able to find any other problems, combined with very, very low current draw, I thought, I bet you that CPU is just broken loose a little bit. So I applied just a baby amount of flux, and I warmed it up, and I gave it just the ever so gentlest float. And guess what happened? Absolutely nothing. The symptoms were exactly the same, and nothing changed. So I put it back in the basket, and I threw it back on the shelf for a while, and I came back to it a few days later. So again, without having schematics, I go completely nuts. I get out my multimeter in diode mode, and I check every stinking line that I can find all over this entire board, and this one right here, all of a sudden, I found was like 0.02 to ground. This line right here was completely, totally shorted. So I got rid of that short, but what I found out next was possibly just a little bit of a kick in the stomach. Whenever I would hook power to this board and prompt it to boot, the CPU would get hot. And it looked to me like the RAM was getting hot. It looked like the RAM was shorted. So from there, there's just nowhere else to go. If the RAM's getting hot, the RAM needs to come off. Now, I have done a good handful of iPhone board swaps, but I've never done anything other than iPhone board swaps. So I had another LG G5 here, and I decided to use that one for just a little bit of practice, and assuming I was going to need RAM, I went ahead and removed the RAM from that G5, and I did a practice run reballing it, and that also let me verify that I had the correct stencils. So once the RAM was reballed, I went ahead and turned back to the customer's board and sliced the RAM off of it, but it was still shorted. So with the RAM removed and the short still there, that means that the short is either the CPU itself or it's one of the balls under the CPU, which dang, you know, in this situation, a phone that's been slammed up against the wall, it would be really easy for me to point fingers at it and say that it was already shorted. And until I found the one short that prevented the boot prompt, I don't know what the behavior would have been before I tried to float the CPU. So I think I'm going to go ahead and probably accept blame for that. So I went ahead and removed the CPU from the customer's board and I cleaned it up nice and pretty. And then I slapped some brand spanking new leaded balls on it. I turned back over to the donor board out of my G5 and I went ahead and cleaned everything up, shined up all the pads, and I got that thing ready to receive a brand spanking new CPU and eMMC flash memory. Now for the RAM, I went ahead and used the known good RAM out of the LG G5 that I had that was booting and working. You know, I just wanted to be absolutely sure. So I start by finessing the entire board up to temp. I'm using a large nozzle with my temperature set at 250 degrees C. And I spend a couple of minutes just sort of going over the entire board to just raise the temperature of everything, because we don't want to just come in and try to blast this thing with heat. It's simply not going to work. Now, once I feel like the board is up to a desirable temperature, I go ahead and raise my hot air to 340 degrees C, and I start focusing the air more on the CPU and the RAM area. And as I'm doing this, I'm continually checking the corner ball. So I circle around for a minute and I can keep the hot air moving, and then I periodically pause right where my little blade is and I see if that solder is getting molten. When it's not, I continue moving the hot air around and just rinse and repeat until I've got it finessed up to temp to where I can slip this blade in. And here comes the RAM. It's going to come off pretty stinking quick once we get it up to temperature here. Now, I did fumble around here just a bit to to get it off of there, but I'm really careful as the solder melts to back the heat away. And I'm just really finessing this thing and holding it right at a specific temperature. And here just any second, this RAM will flip off of here and we'll see what it looks like underneath. Come on, baby. There we go. Now, at this point, we need to clean up the top of the CPU because, let's face it, this looks like total garbage. What I'm doing right here is I've got a tiny little bit of low melt solder on the tip of my iron. This stuff melts at 138 degrees C, and I'm not touching that CPU with my iron. I am just very lightly hovering this blob of solder just right over the top of the CPU. It takes quite a bit of flux to make this happen nicely, but once we start switching this alloy over from the lead-free garbage that Apple has on here to this low melting alloy that I'm using, we don't have to use near as much heat to get this stuff to flow nicely. You'll see here that all these pads are shining up and they're not giving me one bit of trouble. So with the top of the CPU cleaned up, it is time to go ahead and remove the CPU. I use the same exact temperature settings and I'm just waiting for my blade to slip in there. And just at the right moment, this will flip off the board. Any moment, fellers. There we go. So to clean up the CPU, I've basically just hovered over it with a blob of leaded solder. And here I'm just sort of making the final touches, trying to get rid of any gnarly, snarly, sticky uppy things or anything else that may otherwise make my life miserable. So that CPU is just about cleaned all the way up and ready for some brand spanking new leaded balls. It is the same exact process with the RAM, only we're actually prepping this up to receive something other than leaded balls. Now, it is completely okay to reuse the RAM, but you have to be extremely careful when removing it. One of the reasons I spend so much time finessing the board up to temperature and spiraling the air and moving is because I feel like all of that contributes to less warpage of the CPU and RAM. If you try to rush through this, you wind up with warped RAM, but if you're very careful, and I mean very careful, you can reuse it. So let's get some balls on this RAM, shall we? Oh, look, we've got the right stencil. Now I'm going to begin smushing some low melt paste down in here. This is extremely important for this to be a lower melting alloy than what's on the CPU, because remember, this is going to get stacked on top of the CPU. We don't want to accidentally float the CPU while this is being soldered on. So I know I'm not using the best of tools for this, but it works pretty stinking well. All right, almost there. It may not be absolutely perfect, but whenever you're doing this under a microscope, you can get it pretty close. So I'm going to start warming this up with hot air. Now, I am using lower temperatures here than probably any of you have ever heard of me using. I have got my hot air set at 205 degrees C with an airflow of 25. I've got the air moving really slow and I've got the temperature really low. And my goal here is to keep the stencil from warping while I gradually finesse the entire area up to temp, and I'm going to work this in right here at the corner. Almost there. It's going to start to melt here at the bottom left corner first, and then I'm just going to carefully work this around the ram. I'm probably just a little bit too cool on temps. I could go a little bit higher than this, but I'm just being excruciatingly careful, folks. All right, here we go. This is getting a little bit easier. I'm going to go ahead and leave the video part of this reballing process unedited here so you can see me follow around the ram. I don't do it all at once. I'm sort of reballing it around the perimeter. Now, if I was really careful, I could just probably warm the whole thing up and let all the balls form at once because we are using low melt. That would actually work out. So focusing on the top right-hand corner of this job here, I'm just waiting for the temperature to come up far enough for it to begin melting solder paste into balls. Come on, baby. Looking really good. I like to heat it just a little bit farther beyond that to try to make sure everything has melted and has dropped out of the stencil so none of the balls stick, but that's not going to be a problem because we have a fresh stick of RAM here with some nice balls on it. I'm going to carefully finesse these balls into floating just one more time to try to make sure everything is attached. And when I say carefully, I mean real carefully. I think at this point I'd actually even reduced my temperature down to 195 C. You don't need 205 C at this point, not with 138 degrees C alloy. So let's slap some new balls on that CPU, shall we? This is basically the same exact process, only I'm going to be using leaded 6337 solder instead of low melt. Now, this is a little more difficult because we're going to be using higher temperatures, and with the higher temperatures, it's a little more difficult to keep the stencil from warping as you start to warm it. So I'm just going to get all of the holes filled with some nice leaded solder. Oh yeah, baby. Nice and pretty. Once I got it all smoothed off with my blade, I usually sort of go through there once or twice with my finger just to make sure everything's smooth. There we go. Oh yeah, that feels good. I'll just wipe the rest on my pants. So here we go. I've got my hot air set at 300 degrees C with an airflow of 25, and I am finessing this up to temp. And at the bottom left of your screen, you will see these balls starting to form. And again, being very careful not to let the stencil warp. I'm always moving the hot air around and always watching and feeling for the stencils to start to change shape. But when using as low of a temperature as possible and a really low airflow with a really big nozzle, it really makes this reballing process a lot easier. And you can see here, I've just about got the entire CPU's balls formed. Come on, baby. We need some data here, right? Now, once it's all melted, I'm heating it just a little bit farther again to make sure the balls have dropped out of the stencil if they're stuck. And if they are stuck, you can use a little bit of flux and that'll make them drop. Oh yeah, baby. Isn't it gorgeous? It's just marvelous. All right, everybody. I have a confession to make right now. When I first went to reball this CPU, I didn't realize my stencil had a cutout for these capacitors, so I had actually removed the capacitors. And then I realized that I had the stencil upside down, so I actually put the capacitors back on. I didn't record that part, but it really is worth mentioning. Now, the top of the CPU looks really good, other than my hairy fuzz all over the place. So now it's time to get some nice shiny balls on the memory. This is the flash memory chip that actually contains all of the data. I have this packed with 6337 leaded solder paste, and I am now finessing it up to temp. This is actually the last chip that I have to reball in order to start getting this stuff crammed onto another board. The moving of the hot air and this circular motion you see is a finesse that I'm doing to gradually bring this up to temp and coerce this stencil into not warping. And here we go. We got some nice leaded balls forming from the bottom left to the top right. Yes. Isn't it lovely? We have us a nicely reballed flash memory chip here, and wait a minute. This thing is missing a ball. How do you like that? Reball the entire CPU and the RAM and not miss a single ball. Maybe I can just dig the missing ball out of the stencil. That way it's the proper size, right? Come on. You know you want to get back on that chip where you're supposed to be. Right there. Right like that. So it's a little tricky to apply flux without washing the balls away. So let's see what we can do here. Oh, it's so close. I'm trying to just barely brush it with some flux, because if I touch the ball, it's going to suck up onto my syringe. All right, better hold this thing in place with tweezers. And here we go. I'm just going to hold it there and warm it up a little bit. And just after it starts to melt, I can let go of it with my tweezers. And then that sucker will float right down into place. Ta-da! No more missing ball. How about that? So with that, I had everything reballed that I needed reballed. I had the donor board prepped up and ready to receive the new chips. Now, I apologize, but I didn't actually record the prepping of the donor board. And also, one really important thing that I have left out here is flux. To put this CPU on the board, we need to use just a tiny amount of flux. So I take and I put just a blob of my normal chip quick flux in the middle, and then I use my finger and just smear it around, and then I literally wipe almost all of it off the board to where there is just hardly any flux left. So I like to align the CPU using a microscope, but once it is aligned, then I like to just switch and use my eyes, because I'm needing to see under the side of the CPU anyway, and not necessarily from the top down. I have got my hot air set on 330 degrees C with an airflow of 40. I'm just finessing this thing up to temp here and watching for something to start to melt. We want it to settle down onto the board just as evenly as possible. So I'm continually swirling the hot air around, and I'm moving and moving and moving, and I'm being extra careful not to just spray it all in one spot. And I'm also leaving this in real time, so you can see this CPU begin to settle down onto the board. Any moment. Here we go. Drum roll, please. Wait, that's not actually going to work in this case, because this is really slow. This actually starts out slow and then eases right on off a little bit. All right, there we go. It's starting to float down onto the board. Very nicely. Now, notice how we don't have any flux bubbling out from under the CPU. That is because I used a tiny amount of flux. I put the flux on the board, and then I actually wiped it off. And flux not bubbling is absolutely critical to successful CPU rework. The bubbles will actually nudge the solder balls around, and all hell will break loose under your chip, and it won't work. In fact, it'll most likely be shorted. So very little flux, no movie balls, no shorts, functional CPU. And I heat it up until I see that the side that settled first actually raises up a little bit. So what that tells me is that the far side has actually settled down. There we go. So then I do the same exact thing with the flash memory. This is also being done at about 330 degrees C, which honestly is probably a little hot for leaded solder. So we just want to make sure that this thing settles down onto the board all the way across and goes nice and flat, just like that. Oh yeah, baby. How did I seriously not record the soldering of the RAM? Okay, so I didn't record the actual soldering of the live customer's device, but I do have a practice run, which looked pretty much identical to the actual run. For this, I'm using a much lower temperature. I believe this was down around 250 degrees C, and I'm just trying to be absolutely careful not to float the leaded solder underneath. And basically, we just warm this thing up until it settles on top of the CPU nicely. So once I had the board put together, the CPU, the RAM, and the flash memory all soldered on, I was really excited to push that button to boot, but absolutely nothing happened. So I decided to check the charging current, and whenever I plugged in a USB-C cable, it goes zzz and springs into life. And I've got to say, I don't think this feeling will ever get old, to go through that many connections and have things work. It's pretty spectacular, really. So I was able to make a full backup of the user file system, and then also able to make the proprietary LG, LBF, whatever backup it is. But since this was my very first non-Apple swap, I actually learned quite a bit while I was doing it. I learned that we only had to swap the CPU and the memory, and Wi-Fi and baseband seemingly still works. So without swapping baseband or anything, this phone actually has working cellular service and also working Wi-Fi. So that's actually pretty stinking cool. Swap the CPU and eMMC flash memory only. So there you have it, folks. This is a successful recovery and is also my first full board swap video on YouTube. So I'm going to be posting quite a bit more of it. And if you like this type of thing, I would greatly appreciate it if you subscribe, give me a thumbs up, all those good things. And yeah, that's it for now, everybody. Thanks for watching. I'll see you soon.